My name is Bukya Krishna, roll number 20951A2130, branch Aeronautical Engineering. So today my topic is thermal stress analysis for rapid thermal processor. First, what is thermal analysis? Thermal analysis is a branch of materials science where the properties of materials are studied as they change with temperature. Several methods are commonly used. These are distinguished from one another by the property which is measured. Dielectric thermal analysis DEA, dielectric permittivity and loss factor. Differential thermal analysis DTA, temperature difference. Differential scanning calorimetry DSC, heat difference diametry, DIL, volume. Dynamic mechanical analysis DMA, mechanical stiffness and damping. Evolved gas analysis EGA, gaseous decomposition products. Laser flash analysis LFA, thermal diffusivity and thermal conductivity. Thermogravimetric analysis TGA, mass. Thermomechanical analysis TMA, dimension. Thermo-optical analysis TOA, optical properties. So these are the thermal analysis and common thermal analysis method and the properties measured. So here I have given method and their abbreviation and property measured. Differential thermal analysis DTA, temperature difference. Differential scanning calorimetry DSC, enthalpy. Thermogravimetric analysis TGA, mass. Dynamic mechanical analysis DMA, deformation. Dielectric thermal analysis DEA, deformation. Evolved gas analysis EGA, gaseous decomposition. Thermo-optical analysis TOA, optical properties. Thermal analysis is defined as a series of techniques for measuring the temperature dependency of a physical property of a certain substance while varying the temperature of the substance according to a specific program. The substance referred to here includes reaction products. Physical properties include mass, temperature, enthalpy, dimension, dynamic characteristics, and others. And depending on the physical properties to be measured, the techniques of thermal analysis. Introduce thermal analysis at any entry level chemist or a new function for the experienced pharmaceutical scientist. This teaching tool describes the introductory use of differential scanning calorimetry DSA, thermomechanical analysis TMA, and to some extent thermogravimetric analysis TGA for characterizing pharmaceuticals. The main objective to introduce thermal analysis and its application at an entry level in the pharmaceutical industry. In this process, instruments were successfully calibrated using pharmaceuticals. Studying the behavior of pharmaceuticals by different thermal analysis instruments under different conditions and then compared to results was another objective. Modern instrumentation used for thermal analysis usually consists of the following parts: sample holder, compartment for the sample, sensors to detect, measure a property of the sample and the temperature, and enclosure within which the experimental parameters, that is temperature, speed, environment, may be controlled. A computer to control data collection and processing. This is the temperature control furnace and the sample sensors. Then go to PC processing. Thermal analysis of pharma materials. DSC, TG, DTA, and TG by DTA IR are often used for characterization of pharma materials. DSC alone or in combination with the hot stage microscopy is able to differentiate between different polymorphic structures and by using different heating rates can investigate the transformations which occur during the polymorphic transformation. By using appropriate heating rates, polymorphic purity can be determined and can involve heating rates up to 750 degrees Celsius per minute. TGA is often used to measure residual solvents and moisture but can be also used to determine solubility of pharma materials in solvents. Analysis of pharma materials is probably the largest area of application for thermal analysis. Rapid thermal processor. Rapid thermal processor (RTP) is a semiconductor manufacturing process which heats silicon wafers to temperatures exceeding 1000 degrees Celsius for not more than a few seconds. During cooling, water temperatures must be brought down slowly to prevent dislocations and water breakage due to thermal shock. Such rapid heating rates are often attained by high intensity lamps or lasers. These processes are used for a wide variety of applications in semiconductor manufacturing, including dopant activation, thermal oxidation, metal reflow, and chemical vapor deposition. One of the key challenges in rapid thermal processing is accurate measurement and control of the wafer temperature. Monitoring the ambient with a thermocouple has only recently become feasible in that high temperature ramp rates prevent the wafer from coming to thermal equilibrium with the process chamber. One temperature control strategy involves in situ pyrometry to effect real-time control used for melting iron for welding purposes. Rapid thermal anneal (RTA) in rapid thermal processing is a process used in semiconductor device fabrication which involves heating a single wafer at any time in order to affect its electrical properties. Unique heat treatments are designed for different effects. Wafers can be heated in order to activate dopants, change film to film or film to water. Wafers substrate interfaces density deposited films, change states of grown films, repair damage from ion implantation, move dopants or drive dopants from one film into another or from a film into the water substrate. Rapid thermal anneals are performed by equipment that heats a single water at a time using either lamp based heating, a hot chunk, or a hot plate that a water is brought near. Unlike furnace anneals, they are of short duration, processing each water in several minutes. Thank you.